All right, we have this simultaneous equation on the board here, and it said solve the simultaneous equation using the Cramer's rule. Now let's see how we can attempt this simultaneous equation using Cramer's rule. There are so many methods. I think about 6 methods we have, or that can be applied in solving simultaneous equations. But in this case, we're going to use the Cramer's rule to solve this simultaneous equation. Meanwhile, I would like to solve this using the substitution method first before applying the Cramer's rule, in solving this particular simultaneous equation. All right, let's go ahead. So first of all, I would like to solve this using the substitution method. And to solve using substitution method, I would like to make y the subject of the formula, say in equation 2. And that would be that it will mean that y will have to be equals to 4, and I'm taking my minus 2x to the other side to make it a positive 2x. And these will be substituted into any of the equations. So I'm going to substitute this into equation 1. And if I'm to substitute this into equation 1, it simply means that anywhere I find y, I am going to, substitute 4 plus 2x for y in equation 1. So let's go ahead and do that. That will mean that 3x plus 2, instead of y, I'm going to replace y with 4 plus 2x. It's going to be all in bracket 4 plus 2x equals to 1. So let's solve this. So that means that we're going to have 3x plus 2 times 4 is going to give me 8. 2 times 4x is going to give me, 2 times 2x is going to give me 4x equals to 1. Then I'll go ahead and collect like terms. Collecting like terms means that you have to look out for variables and constants. In this case, we have 4x and we have 3x and we have 8 and 1 as the constants. So therefore, 4x plus 3x is going to give you 7x. Now, plus 8. Let's go ahead and shift this to the side. Let's bring our constants to the side. And when we do that, it's going to be minus 1 equals to 0. Therefore, 7x will be equals to, well, let's say 7x plus, because 8 minus 1 is going to give us 7. All right, 7x plus 7 will be equals to 0. 7x equals to minus 7 when the positive 7 goes to the other side. All right, so I will still write that here. 7x equals to minus 7. So what I'm looking for here is actually the value of x. Therefore, I'll go ahead and divide both sides of this equation by 7. That is the coefficient of x. Therefore, my x will be equals to 7 is going to cancel 7, leaving me with x. Minus 7 divided by 7 is going to give me minus 1. Minus 1. So I'm going to substitute minus 1 for x in this very equation here. Y equals to 4 plus 2x. So let's go ahead and do that. Y equals to 4 plus 2x. Therefore, y is going to be 4 plus 2, all in brackets. Instead of x, I'm going to substitute minus 1 in place of x. That would mean that 4 plus is going to be 4 plus minus 2. Sorry, positive 2 times minus is going to give me minus. So I'm going to have a minus here, please. Let's always pay attention to our signs. So that means I'm having a minus 2 here, which will be equals to 4 minus 2 is going to give me 2. So the value of my y is 2. The value of my y is 2. My y is 2. My x is minus 1. This is substitution method of solving this particular simultaneous equation. I would like us to use the Cramer's rule. I'm going to rub the board and also use the Cramer's rule to solve this particular equation, please. So now, and I would like you to pay very close attention to that. Meanwhile, as the video continues, please kindly hit the like button and follow us for more, educative content. So now let's go ahead and find out how we can solve the Cramer's rule, and we can solve this particular simultaneous equation using Cramer's rule. To be able to do that, we have to generate a 2 by 2 matrix from this. We're generating a 2 by 2 matrix from the x positions and the y positions, taking advantage of the coefficient of each of the variables. So let's go ahead and do that. That simply means that we're going to have it that in this case we have the coefficient of x to be 3, and we're having the coefficient of x here to be -2, and I have the coefficient of y here to be 2 and 1 here. So this is a 2 by 2 matrix, and this equals to the constant here. All right, so this equals to this. The first thing we're going to do will be for us to find the determinant of this particular matrix. Now, to do that, it's going to be, let's call it D, and D will be equals to, we're multiplying across the diagonals. The first thing we do is to say 3 times 1 is going to give us 3, minus 2 times 2 is going to give us, -4. So let's have it in parentheses because of the sign outside. All right, so now this will be equals to there's a -1 here. Always know that outside every parenthesis, there's always a -1 or a +1, depending on the case. In this case, we have a negative here. Therefore, use that to treat the, the figures or the variables or the constant inside the parentheses. So let's go ahead and use that idea to apply here. And that means that we have a -1 here. -1 times -4 is going to give us a plus. So it's going to be 3 plus 4. That means our D is equals to what? +7. So now, the next thing we're going to do is this. We are going to look for dx. And to look for dx, dx is going to be equals to, we're going to form a 2 by 2 matrix also. But to be able to do that, we're going to suspend the value or the coefficient of dx, and we form a matrix using the values of y and the constants. Can we go ahead and do that and see what the outcome is going to be? So what's the value of y here? The value of y here is the position of y, please. This is a constant, so let's bring in our constant first, please. 1 and 4. And the position of our y is at the other side of the matrix, so let's just have it at the other side. And 1. So please always mind your signs. I made my x a constant, so I'm not using the coefficients of my x. I'm using the coefficients of the y and the constant outside. Now, just like we did before, we're just going to go ahead and multiply through. So this will be equals to 1 times 1 is going to give you what? 1. Okay. Then 4 times 2 is going to give you what? 8. So we're subtracting. 1 minus 8 is going to give us -7. -7. So let's leave it there and look for dy. dy is going to be, dy will mean that we have to suspend all the coefficients of y and then use the values of the coefficient of x and then the constants outside. Now, since x is To the right, to the left side, we're going to just bring in 3, bring in minus 2, bring in our constant 4 to form a 2 by 2 matrix. Now, let's go ahead and do the same thing. Multiply out 3 times 4 is going to give you what? 12. Minus 2 times 1 is going to give you minus 2. Like I always said, there's always a minus 1, invisible minus 1 here. Use it to multiply your parentheses to deal with your sign. That simply means that you'll be having 12 plus 2, which will be equals to 14. So now we have our dx and dy. To be able to find the final value of y, we're dividing our dx by the value of d, please. Divide your dx by the value of d and divide your y by your dy by the value of y. Now, to find the values of y and the values of x, let's go ahead and find the value of x. It simply means that what? The value of our x here is what? We're finding what? Dx all over d. That will be equals to the value of our x here is what? Minus 7. Minus 7 divided by what? The value of d. And d here is 7. 7. This will be equals to minus 7 divided by this is going to give you minus 1. Now, for the dy, we have our dy here. All over d. Dy is what? 14. Equals to 14. Divided by what? Our d. Our d is what? 7. This will be because 14 divided by 7 is going to give you 2. So with this, we've been able to find or to solve this simultaneous equation using Cramer's rule. But one thing I want to draw your attention to is the fact that you need to consider the values of the first equation we solved using substitution method. In the first instance, we used substitution method to solve this, right? And we got the value of y to be 2 and the value of x to be minus 1. And using Cramer's rule as well, we also solved this same equation and we had the value of x to be minus 1, just like what we have here. And then also similarly, we are also having the value of y to be what? 2. Therefore, this is one of the methods you can use to solve your simultaneous equation. Yes. So I believe you got value, in our lesson today, and I want you to hit the like button and subscribe to our channel for more educative contents. Thank you very much. See you in the next video. Thank you.